right, in this problem, we're given some data about the number of people in an arena T minutes after an event has ended. So the independent variable here is the time in minutes after the end of an event, and the dependent variable Y is the number of people that remain in the arena. So our first task is to use Desmos regression tools to find an exponential equation that best models this data. So we're going to do an exponential regression using the data here in the table. So I have a Desmos calculator window open here. I'm just going to carry my data over here into Desmos by copying and pasting the table values. Notice I'm not including the header rows. I just want the numerical data. So I'm going to Control C that data that I've selected to get into my clipboard, and then go over here into this first row and Control V. And now I have my data over here in Desmos. Now I want an exponential equation to model the data. So I'm going to go up here to the regression icon and add regression. So I click on that, and as always, the regression is going to default to a linear regression model. That's not what we're asked to do. I want an exponential equation. You can see by looking at the data that it looks like an exponential equation might be a better fit. So I'm going to drop down in the options here in the regression calculator, and I'm going to pick exponential regression. And then, as we always do when we're doing Desmos exponential or log regressions, we're going to select log mode. So when I do that, you can see that I've got a very high R squared. You can see the curve over here. It looks like a very good fit, close fit to the data. So the actual regression equation is given right here in my model. And so I'm going to type that over here into the first part of my question. So the regression model we have here is y regressed on A times B to the X. And so that's the equation that I'm given is in that form. Pay close attention to the rounding instructions. Here we want to round the values to 3 decimal places. Also keep in mind that even though the equation over here in Desmos uses X as the variable, the equation that we're looking for over here in MyOpenMath has T as the variable. So I'm just going to swap out the X that I see in the Desmos model for the variable T. So that's my regression equation. Now in part B, we're going to use this equation, and it's very specific in these directions that we're going to use this equation with the rounded values. That's important because if I have a different rounding in the equation, I'm going to get different results down here. We're going to use this equation to estimate each of the following. So I want to make this easy on myself over here in Desmos. So since I have to compute 3 different values, I'm going to go over here in Desmos, and I'm going to hover over this equation icon here, which lets me enter the snapshot to the expression list. And when I click on that, you can see that what it does is it drops my regression equation down here into a separate line in the calculator for me. Now, I'm just going to edit this a little bit to write this as a function f of T, or you can use X here. It doesn't really matter. Again, that's just a placeholder. But I am going to round these values. So the equation that I have here with the rounded values is exactly identical to the equation that I answered over here in part A. So now I have defined my regression equation over here in Desmos as a function. Why that's helpful is then for each of these parts where I am estimating the number of people left in the arena after certain number of minutes, I can just use this function definition and evaluate for the appropriate value of the input variable. So the number of people in the arena 19 minutes after the event ended, that is just f of 19. I'm going to round to the nearest whole number. So I get 49 12. The next is how many people were in the arena 56 minutes after the event ended. So that's going to be F of 56. And the last one is how many people were in the arena at the exact moment the event ended. So the exact moment the event ended, that's when the time is equal to 0. So I can evaluate that here, but I just want to point out that the result that I'm going to get when t is equal to 0 is exactly the value of A. That's what A represents. It's our starting amount or starting quantity.